Check. Check. Check, check. Check. You gonna go in there and check things out? What's up, Cam Dog? Okay. All right. There. Stop that. Hey, it's a dog. It's a dog. Hey, dog. Well, I am on here, but it says that no people are watching. So, there may be people watching. Let's see. Well, I am on here, but it says that no people are watching. So, there may be people watching. Let's see. Send me an email if you're on. Tell me what you're going to do, what you'd like me to do, problems or whatever, and I will do them. And I'm trying to find. Trying to find a place where you can comment. If on my computer, I have a chat area. But I don't see it on the phone that I'm looking at. I just hit the like button and I saw it registered. So maybe if you're listening, if you hit the like button or the down button, I don't know. Down button doesn't show up, so you gotta like it to see, so I can see who's on here or how many people are on here. Okay, so still here, not able to see if anybody is watching. Send me an email if you're wanting me to do some problems, or just to let me know you're waiting and you're at this site. I sent a new link. So send me an email, or if you can, if you're at a computer and you can see a chat area, you can chat. I'm on my phone and I can't see how I can add a comment. So we'll have to do it through email, or if you're on the computer and you see a chat area. I'm not sure. But I am assuming nobody is here. Also, you can like, if you hit like, that shows up. I'm not sure why the viewer count isn't working, but the like button works. So if you hit like, I'll see that you're here waiting for me. So reach out through email or the like button, or if possible, the chat button. Hello? Who is on and what would you like me to do? I can't see who's on and I don't know what you'd like me to do. So there are ways that you can communicate with me. One, you can email me at dwmills@waketech.edu if you are watching, or you can hit thumbs up, which I'm assuming that this person, I see that one person is in, and that that's probably good enough. But I'm still not sure. So if you hit the thumbs up, that would be great. And then you can go to Twitter and ask me a question. If you want me to do some problems, just let me know what you want me to do. I'll be here till 11 or so. So, or I'm on a computer and I see where I can chat, but I can't find that on my phone. So I don't know if that's a setting that I didn't hit. So somehow we've got to figure out a way to communicate. And I'm refreshing my email constantly. So hit thumbs up if you hear me. Email me. Or go to Twitter. And okay, so I have either 1 or 0 subscribers. That 1 subscriber might be me because I'm on my phone. So I need anybody who can hear me to hit the thumbs up on the YouTube screen or email me. Tell me what you would like for me to do, and I'll just start working. Or you can go to Twitter, hashtag WTMAT172, and tell me what you'd like for me to review, and I'll just start doing problems. Hey, Dave. Oh, okay. Nice. Well, I thought I had someone, but that was just someone emailing the course evaluation. Thank you very much. Still don't know if I have anybody on. There we go. I still don't know if I have anybody on. I'm just checking my email. Got no emails. Have only one thumbs up, which I gave myself. And so I'm just waiting here. You can go to Twitter. You can email me. And I will go over some review problems. I think that one person subscribing is just me. So I'm going to leave it. Yep. I think I have two people, or at least one person. Hello. Email me at dwmills@waketech.edu, or you can go to Twitter and hashtag WTMAT172 and just tell me what you'd like for me to do, who you are, and we can review some. I got nothing at Twitter, and now we've gone down to one. So let me know who you are and email me what you want me to do. Unit 3, Unit 4, problems from the course practice, page 65 and following. Let me know if you can hear me. If you hear me, click the thumbs up button. That seems to be going through rather quickly. Okay, so somebody just gave me a thumbs up. So you need to email me. Tell me what problems you want to do, or go to Twitter. if you're on the computer, I can see a chat, but I don't know if you can see a chat. I wish that was enabled. That would be the best. They've changed the way you go live on YouTube, and I haven't mastered it yet. But at least I know I have someone here. I wish you would just reach out to me in some way through email or Twitter. If not, see, I don't want to move this out of the way, but at least I know I have somebody on here. So I will, got 2 people on here. Send me an email or hashtag WTMAT172. I'll put that up here. And let's see, I will start, I guess, problem 1, page 65, I reckon. These problems on this page, on this course review, are all over the place. They go from Unit 1 to Unit 4. So this one, the directions are to solve each equation determining all solutions and also specific solutions. So this first problem, first thing you want to do is solve for the sine function. So you divide by 2. And then we've let theta equal 3x. And then sine of theta is equal to negative 1/2. So that is, what that means is to get rid of sine, we take the inverse sine. And I usually don't show my work because I just know what I'm doing is I'm looking for the angle whose sine ratio is negative 1/2. And I like to draw a picture. So we know that the sine is 1/2 right here at pi over 6. So the sine is negative 1/2 right here and right here. So theta is equal to, this is 11 pi over 6, and this is 7 pi over 6. So those are my 2 theta values, but then theta was not just theta, it's 3x. So then I substitute 3x in for theta, and it equals 7 pi over 6, or 3x equals 11 pi over 6. And remember, before we divide by 3 or multiply by 1/3, we have to account for all solutions. So 7 pi over 6, you have to go all the way around to get back to a coterminal angle. So that's why we add plus 2k pi. And over here, we're going to add 2k pi. And then we have to multiply both sides by 1/3, which would give you 7 pi over 18 plus 2k pi over 3, or 11 pi over 18 plus 2k pi over 3. So those are all the solutions. So it's easier if you find all solutions first. Then you have to find all the solutions from 0 to 2 pi, which is just 1 revolution. So this is all. And so it may make sense to take this and get a common denominator. So that's 7 pi over 18 plus 6 times 2 is 12 k pi over 18, or 11 pi over 18 plus 12 k pi over 18. So your solutions on the interval from 0 to 2 pi would be 7 pi over 18, and then 7 plus 12 is 19 pi over 18, and that's less than 2. And then add 12 again to this, and you get 31 pi over 18. Yeah, 31 pi over 18, and that's still less than 2. But if you added 12 again, you would be over 36. So that's it for this one. And then over here you have 11 pi over 18. And add 12 pi over 18 to this, and you get 23 pi over 18. And then if you add 12 again, you get 35 pi over 18, which is less than 2 pi. But we can't add any more. So those are my solutions on the interval from 0 to 2 pi. So that is 1A. And then 1B, just stop and check Twitter for a second, check my email. My phone's not, there we go. Brody. Hello, Brody. Page 57, number 4. Okay. All right, 57. So 57. Okay, so this whispering room problem says a whispering room is a room where the ceiling is shaped like an ellipse. Someone standing at one focus can hear anything that is said by the person standing at the other focus, even if it is only whispered. Suppose such a room is created with a ceiling that is 20 feet above the 5-foot vertical walls. So we start with 5 here and then add 20 at its tallest point. That means the center. Therefore, the cross-section of the room is half an ellipse on top of 2 vertical lines as shown below. Suppose the height above the whispering points is 21 feet. So that would be 5 here. That's why this is 16. How far apart are the whispering points? Okay, so we need C. We have C here and C here. And so we know that this is a horizontal major axis, and we can just define this point if we want to be 0, 0. So that's going to give us x squared plus y squared equals 1. And now I'm looking for a squared and b squared. A squared is always bigger, and it's going to be underneath x. This is it's not the major axis. This is not A, this is B. And from the center, it's going up 20, so that's 20 squared right here. And so we're looking for B. We don't have B. So, I'm sorry, we're looking for A. We don't have A. So I'm going to put that there. But we do have a point. We know that this point right here from the origin is over C up 16. We don't have that point. Okay, we have let's see. We have this point is 0, 20, but that's not going to help us find anything. You know, that's C 16. I don't remember how to do that problem. Let me look it up. I don't have enough time. Let's see. 57. Okay. Oh. oh, this one is quite a difficult problem. I was in my head thinking it was going to be a little bit easier, but it is not. Okay, so we have two unknowns is the problem. We don't know a squared and we don't know c squared. So we do know that c squared equals a squared minus b squared. So that means that c squared is equal to a squared minus 400. And we can solve for a squared. So c squared plus 400 equals a squared. So I'm going to rewrite this equation as x squared over c squared plus 400 plus y squared over 400 equals 1. Then this is what we're going to use right now. So this problem is quite tricky because x squared and y squared, this is the point. This is our x and that's our y. Usually we can plug both of those in, but we don't have it. So what I'm going to do, if x is c, I can put c right here and get c squared over c squared plus 400. And then 16 here, and 16 squared is something, equals 1. Let me see what 16 squared is. Okay, 256. So c squared over c squared plus 400 plus 256 over 400 equals 1. So we're going to solve for c squared by subtracting. So that's going to give us c squared over c squared plus 400 equals, let's see. All right. So if we subtract 1 minus 256 over 400, you get 144 over 400. Okay. Then cross multiply, and that gives you 400c squared equals 144c squared plus 400 times 144 is 57,600. So then if I subtract 400 minus 144, I get 256 c squared equals 5,700. If I divide that by 256, that gives me c squared equals 225. And if I take the square root of that, I get 15. So we have c squared is 225, now c is 15. It says how far apart are the whispering points? So we now know that that is 15 and that is 15, so they are 30 feet apart. Okay, so that's a little harder than what we've done because you had to realize that you do use this, but we don't know A or C, so we had to solve for A, and then that's a little tricky there. And then knowing that you do need to find a point to plug in. Usually we're given an X and the Y, but this time we were given C because you're going over C, and you had to put C in place of X. A little tricky there. Hello, Hassan. You found the chat. That is awesome. Okay, so Hassan wants to do page 26, number 11. Okay. Get there. Okay, so you need your trig identities for this one. And I have to find mine. Page 26, number 11. Okay, so it says use addition and subtraction formulas to write each expression as a trig function or number, then determine its exact value. So A is cosine 4 pi over 7 times cosine 5 pi over 21 plus sine 4 pi over 7 sine 5 pi over 21. So you'll be given the addition and subtraction trig identities. I just have to find mine. I don't remember what page they are on. Let me look that up. I have to find it in my notebook, which is somewhere. Okay. Just a second. If not, I'll find it in the lab manual because, let's see. Well, looks like I took out my copy. All right, where is it in the lab manual? Let's see. Oh, 64. I just missed it. So we're looking for the angle, the sum difference formulas. So if you can see right here, this has cosine, cosine plus sine, sine. So there it is. Cosine, cosine plus sine, sine. So you can see that cosine A, cosine B plus sine A, sine B is equal to cosine A minus B. Okay, so this equals cosine A minus B if we look at the formulas. So A, we're going to say, is 4 pi over 7, and B is 5 pi over 21. So this equals cosine of 4 pi over 7 minus 5 pi over 21. You get a common denominator of 21, and that's times by 3 over 3. That's 12 pi over 21 minus 5 pi over 21. So cosine is equal to 12 pi minus 5 pi, which is 7 pi over 21. And you always have to reduce. That's pi over 3. So that's A. And then B is a tangent one. Tangent of 51 degrees minus tangent of 21 degrees over 1 plus tangent 51 degrees tangent 21 degrees. Oh, do you switch the page number on me? Do you still want me to do page 26? Because I can go to 21. All right, I see it's an equation. I'll just finish this one out just in case. But this is a tangent, and the formula for tangent, looking for tangent, there it is. Tangent of A minus tangent of B is 1 plus tangent A tangent B. That's tangent of A minus B. So this is A and this is B. It equals tangent of 51 minus 21, which is tangent of 30. And let me read the directions before I move on. Oh, yeah, we have to go further. So we have to then determine the exact value. So back over to this one, cosine of pi over 3 is 1/2, and tangent of 30 is square root of 3. Okay, page 21. All right, so that's finished that. And those are your trig identities. So you'll be given those. You just have to find them and then replace the angles. And then page 21 is an equation. And it is number 11, page 21, number 11. It looks like a hard one, so I'll do it. 3 times sine cubed x plus 6 sine squared x plus 3 sine x. It just is a, all you have to do is factor on this one. So we don't have to solve this or anything. We just have to factor this. So you have to make sure if you're going to pull out a greatest common factor, it has to be in all three terms. And you can pull out a 3 and a sine of x. So if you pull out a 3 and a sine of x here, you're left with sine squared x. If you pull out a 3 here, you're left with 2. And if you pull out a sine, you're left with just 1 sine. Here, if you pull out 3 sine x, you're left with that positive 1. So now we still have to factor because this factors. So this is 3 times sine of x times, you can put a sine of x here and a sine of x here, and then you're going to look for the factors of 1 that add it to be 2, and that's 1 times 1. If you were to multiply this back out, we would get that. So this is completely factored now. Okay, so let me check email, check Twitter. I'm so glad Hassan has found the chat area. Didn't show up on my phone. Brody, hopefully that helped you with number 4. And I'm just updating, and I don't have any more emails, and I don't have any more text messages, chat messages, and I don't have any Twitter hashtag WTMAT172. And those were good questions. It is really snowing right now at my house. Okay, now we got page 26. Hassan says 9b. Oh, an identity. Yes, okay. So 9b is 1 minus tangent squared x plus 2 over secant squared x. All right, now at the risk of bumbling this, I'm not going to look at the key. I'm going to just try to figure this out. Usually when I have two terms and one's a fraction, I start by trying to get them just one fraction. So I think that's what I'm going to do. Let's see what happens. So if I make this 1 over 1, then the common denominator is secant squared x. I'm going to multiply both sides by secant squared x. So that's secant squared x over secant squared x minus, this minus belongs to both of these, so I'll deal with that in a second. All right, so now I'm going to add the numerator. So that's secant squared x minus tangent squared x minus 2, because that minus gets distributed over secant squared x. Okay, so now since they're squared, I'm probably going to use a Pythagorean identity. So I need to remember those. And those are, you have to have those memorized. So I know sine squared x plus cosine squared x equals 1. And if I divide both sides by cosine, I get sine over cosine, which is tangent squared x, plus 1 equals 1 over cosine, which is secant squared x. Okay, so that's what I'm going to replace secant squared x with. Secant squared x equals tangent squared x plus 1. So this becomes tangent squared x plus 1, and then we have minus tangent squared x minus 2 over secant squared x. So then these tangent squares cancel, and then 1 minus 2 is negative 1. over secant squared x. Well, secant squared x is the reciprocal of cosine squared x. So this is -1 times cosine squared x, which is negative cosine squared x. And this is 9b. It says to simplify each expression. I think that's it. Let me just grab my key and see what I have there. But once you get it down to one expression, you're pretty much done. So what else would you like for me to do while I'm looking this up? And just to make sure, let's see. Yep, that's as far as you need to go there. Once you get it down to one trig expression, you're done. All right, let me check my email. Oh, good, Brody. I'm glad that it helped. All right. Let me check Twitter. I got nothing there. So anything else, Hassan? Number 7, page 25. Use the addition and subtraction formulas to determine the value of tangent of 7 pi over 12. Okay, so that means on this case, I need to figure out, this is exact answer, so I need to figure out what plus what on the unit circle will give me 7 pi over 12. Well, I know that 7 pi over 12 is 3 pi over 12 plus 4 pi over 12. Okay, so I'm going to rewrite this as tangent of pi over 4, because 3 pi over 12 is pi over 4, plus pi over 3, because 4 pi over 3 is 4 pi over 12 is pi over 3. And then I need to go back to my formula page, because I don't have that memorized, and see what that is, even though we just used it. Here it is. Tangent of a plus b is equal to tangent of a plus tangent of b over 1 minus tangent a tangent b. Okay, so a is pi over 4 and b is pi over 3. So that's going to be tangent of pi over 4 plus tangent of pi over 3 over 1 minus tangent of pi over 4 tangent pi over 3. Okay, so now I have exact values for these. Tangent of pi over 4 is 1. Tangent of pi over 3 is square root of 3 over 1 minus tangent of pi over 4 is 1 again, times tangent of pi over 3 is square root of 3. Now I'm getting this because I have it memorized. So remember, pi over 3, the ordered pair is 1/2 square root of 3 over 2. And tangent is the y divided by the x. So that's the same as multiplying by the reciprocal. So that's how I know it's square root of 3. So you end up with 1 minus square root of 3 over 1 minus the square root of 3, which that's just 1. That doesn't seem right. So did I make a mistake somewhere? Let me see. Let's see. That's number 7. Oh, I think I did. I made a mistake. That can't be 1 because we know that that's pi over 4. I turned that minus, that plus to minus for some reason. There we go. So that's it. That's the answer there. right. Anything else? Let me check my email. I don't know if anybody else is going to come because I think I said till 11, but Hassan, if you have any more questions, I can go a few more minutes. You didn't. I'm glad you're here. I was sitting here all alone for about an hour, so I enjoy helping. Let's do this last one. Okay, number 11 on page 60. Okay. All right, so that's going to be conic sections. And 11a says we want to write these equations. So we want to write an equation of a circle with a diameter and endpoints at -3, 1, and -2, -4. Okay, and we want a circle. So the formula for a circle in rectangular form is x minus h quantity squared plus y minus k squared equals r squared. So we need the center. And we know the center happens right in the middle of the diameter. So this is going to be the midpoint formula, which is x1 plus x2 over 2, y1 plus y2 over 2. So the midpoint, or the center, is going to be -3 plus -1. -3 plus -2 is -5 divided by 2. And then 1 plus a -4, which is -3 divided by 2. So that's our center. And the radius is half of the diameter. Okay, so the diameter is the length from one endpoint to the other. So you need the distance formula. So the distance between these two, the distance formula is x2 minus x1 squared plus y2 minus y1 squared, square root of all that. So d equals x2 minus x1 is -3 minus a -2 quantity squared plus 1 minus a -4 quantity squared. So d equals 1, -1 squared is 1, plus 5 squared is 25. So the distance of the diameter is square root of 26. Well, we want the radius, so then we divide by 2. So the radius is the square root of 26 over 2. But in the formula, we want r squared. So r squared would be that squared, which would be 26 over 4, which is 13 over 2. So the equation of the circle is x minus a -5/2, which is plus 5/2 squared, plus y minus -3/2, which is plus 3/2 quantity squared, equals r squared, which is 13 over 2. That's the equation of the circle. And then that's A. And then B, equation of the circle with center 4, 3 and tangent to the y-axis. Well, I better draw a picture for that. This is the y-axis. 1, 2, 3, 4, 1, 2, 3. This is the center. If it's tangent, that means it's going to touch the tangent only in one place, which means that if you went over 4, that means the radius length is 4. So since the center is 4, 3, and r is 4, x minus 4 squared plus y minus 3 squared equals 16 is your equation. And then C says parabola. The vertex is 4, negative 1, and the directrix is y equals 2. Okay, so I'm going to draw this picture so we can visualize it. So we have 4, negative 1, 1, 2, 3, 4, negative 1. And the directrix is this horizontal line, y equals 2, which tells me that this opens upside down, which tells me that the formula that we're going to use is x minus h quantity squared equals 4p times y minus k. Well, I already have h and k. All I need is p. And the way you find p, the distance between the vertex up to the directrix is p. So since the vertex is 4, negative 1, and this is y equals 2, p is 3. So that gives us x minus, let's put h in there, x minus 4 quantity squared equals 4 times 3 times y minus k, which would be y plus 1. And that's it. All right. Hopefully that helped. Keep looking at the keys. If you get stuck, you can look at them. I think that's it. Am I right? Oh, good, Hassan. I'm glad that you feel like it helped. All right, have a good afternoon. Hopefully we'll have school tomorrow, but as I'm looking at the snow coming down, I don't think so. And we'll see what happens. Just keep checking your email. All right, have a good day. Bye.